Good morning, students. Today we are going to study some more topics about conductance. The reciprocal of the resistance of the solution is known as conductance. It is represented by C is equal to 1 upon R. That is, it is equal to kappa A upon L. It is expressed in the unit called reciprocal ohm, that is ohm inverse, or it is represented as mho. In SI system, the unit of conductance is Siemens. Here A is the surface area of each electrode. L is the distance between the electrode and K is the conductivity. K is the conductivity. Now we come to specific conductance. The resistance of any conductor varies directly with its length and inversely with its area of cross section or cross sectional area. So we can write R is proportional to L upon A, or R is equal to rho into L upon A, where rho is a constant depending upon the nature of the material and is called specific resistance of the material. Rho is specific resistance of the material. If L is equal to 1 centimeter and A is equal to 1 centimeter square, then rho is equal to R. So, specific resistance is defined as the resistance in ohms of a specimen 1 centimeter in length and 1 centimeter square cross section. The reciprocal of specific resistance, that is 1 upon rho, is called specific conductance. Specific conductance. What is specific conductance? The reciprocal of specific resistance. So, we know rho is equal to A upon L. So, K is equal to 1 upon rho, that is L upon A into 1 upon R. 1 upon R is called conductance. So, it is L upon A into conductance. Since conductance is measured in ohm inverse, length in centimeter and area in centimeter square, hence स्पेसिफिक कंडक्टेंस की यूनिट क्या हो जाएगी? ओम इनवर्स सेंटीमीटर इनवर्स. It is represented by kappa K. In SI system, the unit of specific conductance are Siemens meter inverse, where SM inverse, SM minus 1. S is Siemens. Now we come to equivalent conductance. Equivalent conductance is defined as the conducting power of all the ions produced by 1 gram equivalent of an electrolyte in a given solution. Equivalent conductance is the total conductance of the ions produced by 1 gram equivalent of an electrolyte in a given solution is known as equivalent conductance. And now we come to, suppose we have 1 gram equivalent of electrolyte dissolving in a solution, then the solution total conductance of the solution is known as equivalent conductance. Now we come to relation between specific conductance and equivalent conductance. Imagine 1 cc of a solution of an electrolyte is placed between two large electrodes which are 1 centimeter apart. The area of cross section of solution will be 1 centimeter cube. The conductance of the solution will evidently be its specific conductance because we are having 1 centimeter cube of the solution. 1 cc cube, 1 cc की solution की जो conductance है, that is specific conductance. Further, if 1 cc of the solution contains 1 gram of equivalent of electrolyte dissolved in it, then according to the definition, the conductance of the solution will be equal to its equivalent conductance. So we can write conductance is equal to specific conductance, and it is also equal to the equivalent conductance. Now, conducting power of all the ion produced by 1 mole of the electrolyte in a given solution is known as molar conductance. Molar conductance is the conductance power of all the ions produced by 1 mole of electrolyte in the given solution. 1 ग्राम इक्वलेंट है अगर तो हम कहेंगे इक्वलेंट कंडक्टेंस, और अगर 1 ग्राम मोल आयंस प्रेजेंट हैं सॉल्यूशन में, देन इट विल बी मोलर कंडक्टेंस. इफ 1 equivalent weight and molecular weight are equal, then the equivalent conductance and molar conductance must also be the equal. Molar conductance or specific conductance, or we can say equivalent conductance and specific conductance, are related to the specific conductance by the relation lambda m is equal to kappa upon c. या अगर इक्वलेंट कंडक्टेंस की बात करें तो लैम्डा इक्वलेंट is equal to kappa upon c, where c is the concentration of solution in moles per meter cube, or equivalent per meter cube. स्पेसिफिक कंडक्टेंस की यूनिट है सीमेंस मीटर इनवर्स, और कंसंट्रेशन की है मोल मीटर क्यूब. इसलिए यूनिट मोलर कंडक्टिविटी की होगी सीमेंस मीटर स्क्वायर मोल इनवर्स. Siemens meter square mole inverse is the unit. और इक्वलेंट कंडक्टेंस की बात करें तो इसकी यूनिट हो जाएगी सीमेंस मीटर स्क्वायर इक्वलेंट इनवर्स मोलर कंडक्टेंस. सी पावर ऑफ कंडक्टेंस प्रोड्यूस्ड बाय 1 mole of a solution. This is the now we come to variation of molar conductance या equivalent conductance with dilution. Molar conductance of an electrolyte increase with increase in dilution. This may be attributed to increase in the degree of dissociation of the electrolyte. As the dilution increases, the degree of dissociation of the electrolyte also increases. Degree of dissociation is defined as the fraction of total electrolyte in the solution which exists in the form of ions. On dilution, the same amount of an electrolyte is capable of furnishing a larger number of ions. However, the increase in the number of ions on dilution is much lesser than increase in the volume of the solution. Therefore, the number of ions per unit volume per cc actually decreases. Hence, the specific conductance decreases with dilution while molar conductance increases with increase in dilution. Molar conductance as well as equivalent conductance increases with increase in dilution. So, see, this is the variation of molar conductance or equivalent conductance with dilution. Dilution increases, molar conductance increases. Degree of dissociation of the electrolyte also increases. Degree of dissociation is defined as the fraction of the total electrolyte in solution which exists in the form of ion. On dilution, the same amount of electrolyte is capable of furnishing larger number of ions. But what happened? The number of ion per cc decreases because the volume increases much. Therefore, the number of ions per cc volume actually decreases. Hence, the specific conductance decreases, although the molar conductance or equivalent conductance increases with progressive dilution. Now we come to relation between specific and equivalent conductance. अभी मैंने आपको बताया था कि यदि सॉल्यूशन का 1 cc 1 ग्राम इक्विवेलेंट या 1 ग्राम मोल कंटेन करता हो, then the specific conductance and equivalent conductance are equal. Now imagine 1 gram equivalent is present in 1000 centimeter cube of the solution, that is 1 liter. Then we have to multiply the specific conductance by 1000 to get the equivalent and molar equivalent conductance. So, the equivalent conductance is equal to specific conductance into that volume which contain 1 gram equivalent of the electrolyte, or molar conductance is equal to the specific conductance into V, the volume of the solution that contain 1 mole of electrolyte dissolved in it. So, these are all about specific conductance, equivalent conductance, molar conductance, their relationship and their variation with dilutions. Thanks. Thank you.